In this video, we're going to practice solving some absolute value equations together. Now, unlike some of the previous videos where we just had the absolute value expression on one side to start by itself, in these particular practice problems, we're going to have to do a little bit of work to isolate the absolute value expression first. To get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. All right, so for number one, we have the absolute value of x plus 5 is equal to 7. All right, so here's the original equation, and before we can separate this into two different equations to solve for x to get our solutions, what we're going to want to do is get this expression, or the absolute value expression, on its own. So first thing we're going to do is take away 5 from both sides of the equation. That way we can just end up with the absolute value on one side on its own. So you have the absolute value of x is equal to 7 minus 5, which is equal to 2. So for the absolute value of x to equal 2, in one case x would be equal to 2, and in the other case x would be equal to the opposite of that, which would be negative 2. These would be the two numbers that would be equidistant from 0 or 2 away from 0. So the two solutions for this equation would be x is equal to negative 2 or positive 2. Here's another one to look at. Here we have the absolute value of x minus 3 is equal to 7. Just like in the last example, we want to get this expression by itself, whatever's in the absolute value bars. So we can go ahead and get rid of this minus 3 by adding 3 to both sides of this equation. So if we add 3 to both sides, we're going to just get that the absolute value of x here is going to be equal to 10. So what would x have to be so it's 10 units away from 0? Well, x could be equal to positive 10, or x could be equal to negative 10. These would be the two numbers that are equidistant from 0 or 10 units away from 0. So these are our two solutions. For number 3, this one's a little bit different. We have 2 times the absolute value of x is equal to 16. So if we want the absolute value of x to be alone on the left side of this equation, we have to get rid of this 2 that's multiplying by it. So the inverse of multiplying by 2 is dividing by 2. Let's go ahead and divide both sides by 2 here. If we do that, we're just going to have 1 times the absolute value of x, or just the absolute value of x. And on the right side, 16 divided by 2 is going to be 8. All right, at this point, we can just separate this into two different equations. So x could be positive 8, but x could also be equal to negative 8. So these would be our two solutions. For number 4, we have something similar to number 3. We have 3 times the absolute value of x is equal to 27. Just like in the last example, we want this absolute value of x to be alone. So how do we get rid of this 3 that is multiplying by it? Well, we can go ahead and divide both sides by 3. If we do that, we're just going to have this absolute value of x on the left side, and on the right side, 27 divided by 3 is going to equal 9. Now, there are two cases where this would be true. If x was equal to positive 9, this would be true. And if x was equal to negative 9, this would be true. So those would be our two solutions, negative 9 and positive 9. All right, for a fifth example, we have 2 times the absolute value of x minus 7 is equal to 11. All right, so this is the first problem that's a little bit different in the sense that we just want to get this absolute value of x alone. However, there are two pieces that we have to kind of move away from the left side of the equation. Now, just like two-step equations, what we're going to do is start by adding or subtracting first and take care of the constant terms. So let's go ahead and add 7 to both sides. And so if we do that, we're going to have 2 times the absolute value of x is equal to, and then on the right side, 11 plus 7 is going to be 18. We can't go ahead and separate this just yet. We want to get rid of this 2 that's multiplying by the absolute value of x, and we can do that by dividing both sides by 2. If we do so, we're going to get the absolute value of x is equal to 18 divided by 2, which is 9. At this point, we can separate this into two different equations here. So for this to be true, x could be equal to positive 9, but x could also be equal to negative 9. So our two solutions here, we can say x could be equal to negative 9 or positive 9. Now, number 6 is very similar to number 5. In this case, we have 5 times the absolute value of x plus 8 is equal to 43. All right, first things first, let's go ahead and see if we can get this absolute value of x alone, just like in the last example. First, we're going to start by getting rid of this plus 8, or moving it to the other side rather, and we can do that by subtracting 8 from both sides of the equation. Doing so, we're going to get 5 times the absolute value of x is equal to, and 43 minus 8 is going to be 35 on the right side. Now, to get this absolute value of x alone, let's go ahead and divide both sides by 5. 5 divided by 5 on the left side is going to be 1, so we just have 1 times the absolute value of x. And on the right side, 35 divided by 5 is going to be 7. All right, cool. So x would equal 7 here, but x could also equal negative 7. So there are two solutions here, and we'll write them just like that. All right, let's check out number 7. In number 7, we have the absolute value of x minus 5 plus 8 is equal to 9. So we want to get this expression in the absolute value bars alone. So let's go ahead and take care of this plus 8. We can go ahead and move it over to the right side by taking away 8 from both sides here. If we go ahead and do that, we're going to have the absolute value of this x minus 5 is equal to 9 minus 8, which is 1. Okay, now at this point, we can go ahead and separate this into two different equations. So we can say x minus 5. If we can get that equal to 1, we could solve for x. And in the other case, we can set this x minus 5 equal to the opposite of 1, because negative 1 is also 1 away from 0. All right, so we have these one-step equations. Let's go ahead and use the inverse operations. Let's go ahead and add 5 to both sides of both equations. If we go ahead and do that, let's see what we're going to get. For the equation on the left here, this negative 5 and positive 5 are going to cancel out to get 0. And so we're going to get x is equal to 1 plus 5, which is 6. And for the equation to the right, something similar will happen to the left side, but negative 1 plus 5 is going to equal positive 4. So our two solutions here are x is equal to positive 4, or it could be equal to positive 6. For number 8, we have the absolute value of x plus 9 minus 4 is equal to 3. So let's go ahead and get this absolute value of x plus 9 alone first. Let's go ahead and add 4 to the left side and add 4 to the right side of the equation. If we go ahead and do so, we're going to get the absolute value of this x plus 9, and that's going to be equal to 7 on the right side. Okay, so let's go ahead and see. If we can get this x plus 9 expression to equal 7, then that would be good. And if we get this x plus 9 expression to equal negative 7, that would also help us find a solution here. So let's go ahead and take away 9 from both of these equations on both sides so that we can isolate x here. Okay, in both cases, we're going to try to get 0. So for the equation to the left, we're going to get x is equal to, and on the right side, 7 minus 9 is negative 2. And for the equation to the right, we're going to get x is equal to, and negative 7 minus 9, or negative 7 plus negative 9, is equal to negative 16. So our two solutions here are x could be equal to negative 16, or x could be equal to negative 2. For number 9, we have 2 times the absolute value of x minus 3 is equal to 10. So what we want to do is get this absolute value of x minus 3 by itself. So let's go ahead and divide both sides by 2 here. If we go ahead and do that, 2 divided by 2 is going to be 1. And so we're just going to have 1 times the absolute value of this x minus 3. I'm not going to write the 1 though. And on the right side, 10 divided by 2 is going to be 5. At this point, let's see if we can get this x minus 3 equal to 5. That'll help us find a solution. And if we can get this x minus 3 to equal the opposite of 5, or negative 5, that'll find us a solution. So let's go ahead and get x alone by adding 3 to both sides of both of these equations. That way we isolate x by itself. And if we go ahead and do so, we're going to see that x is going to equal positive 8 for the equation on the left, and x would be equal to negative 2 for the equation on the right. So our two solutions here, x could be equal to negative 2, or x would be equal to 8. Here's number 10. Number 10, we have 4 times the absolute value of x plus 7 is equal to 24. All right, let's get this absolute value of x plus 7 alone on the left side. So what we're going to do here is divide both sides by 4. The 4's are going to become a 1 because 4 over 4 is just 1. So we're going to have the absolute value of this x plus 7, and that's going to be equal to 24 divided by 4, which is 6. All right, let's go ahead and separate this into 2 different equations. This x plus 7, if we can make that equal 6, this would be true. And if x plus 7 was equal to negative 6, this equation will help us solve for the other solution for this equation. So let's go ahead and solve these one-step equations. Let's go ahead and take away 7 from both sides of them. That way we get 0 on the left side of each equation. So if we go ahead and do that, we're going to get x is equal to 6 minus 7, which is negative 1. And for our other equation, we're going to get x equals, and negative 6 minus 7 is negative 6 plus negative 7, or negative 13. So our two solutions here are going to be x is equal to negative 13, and x is equal to negative 1. For number 11, this gets a little bit more complicated. We have 2 times the absolute value of this x minus 3 minus 7 is equal to 15. All right, so what we want to do is get this absolute value expression alone first. So let's go ahead and take care of the addition or subtraction. In this case, to get rid of this minus 7, we're going to go ahead and add 7 so that we get a plus 0. If we go ahead and do this, we're going to get 2 times the absolute value of x minus 3, and that's going to be equal to 15 plus 7, which is 22. All right, Next, we're going to go ahead and divide both sides by 2. That way we get a 1 in front and we don't have to write that. And so if we divide both sides by 2, we're going to get the absolute value of this x minus 3 is equal to 22 divided by 2, which is 11. Let's go ahead and separate this into two different equations now. So if we can make this x minus 3 equal 11, then that will help us find a solution. And if we can find out when this x minus 3 is equal to negative 11, that'll be where we can find our other solution. So to solve each of these one-step equations, let's go ahead and add 3 to both sides. And that'll help us isolate x, and we can see what that's equal to. So for the equation to the left, we'll have x is equal to 11 plus 3, which is 14. And for our equation to the right, we're going to get x is equal to negative 11 plus 3, which is going to be negative 8. So our two solutions here, I'm going to write it up here, is going to be x is equal to, we can say negative 8 or positive 14. All right, so here's one final example, number 12. We have 3 times the absolute value of x plus 6 plus 7 is equal to 19. Just like in the last example, let's go ahead and get this x plus 6 expression by itself in the absolute value bars. We're going to go ahead and take care of this plus 7 first. Let's move it to the other side by subtracting 7 from both sides of the equation. So if we do that, we're going to have 3 times the absolute value of this x plus 6. And then on the right side, 19 minus 7 is going to be 12. Next, let's go ahead and divide both sides by 3. That way we have this absolute value expression completely alone. On the left side, we have this x plus 6, the absolute value of it is equal to, and 12 divided by 3 is going to equal 4. At this point, if we can get this x plus 6, let's set it equal to 4. That'll help us find a solution, and x plus 6 is equal to the opposite of 4, or negative 4. That'll help us find our other solution. Let's go ahead and take away 6 from both sides of both equations. That'll help us isolate x. And so we can see here that on the equation to the left, we're going to get x is equal to, and it looks like we have 4 minus 6, which is negative 2. That'll be one solution. And for our equation to the right, we're going to get x is equal to, and negative 4 minus 6, or negative 4 plus negative 6, is going to be negative 10. And so we have two solutions here. X could be equal to negative 10 or negative 2. Those would be our two solutions. All right, so there you have 12 different examples on solving some absolute value equations. Unlike the previous two videos, these particular equations had parts of the equations outside of the absolute value bar, so we just had to make sure we isolated the absolute value expression before we separated into two different equations to solve. If you found the video helpful, please consider giving a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.